Hey everybody, it's time to do problem number 3 on the homework, and it's an inclined plane. Here we go. So first we're going to begin by doing free body diagrams for each mass. All right, so, I can't seem to draw here. So we have mass 1. We're going to draw a very skillfully drawn arrow that represents the tension. Then we're going to have the weight of mass 1 pulling down. And we have a normal force on mass 1. Let's split this into components. So we're going to have m1g cos theta and m1g sine theta. And then for m2, we have a tension force pointing up and its weight pointing downwards. Okay, so let's go ahead and set up the force equation. So for M1, even though we don't have friction, I'm going to still set up the normal force equation in the y direction. Very cute. True, but not useful. And then in the x direction, let's just assume that it's moving this way. And if we're wrong, we'll just get a negative answer for our acceleration. So what we're going to say is ft minus m1g sine theta equals m1 times a. And then for m2, we're going to assume that this direction is the positive direction. So that means m2g minus ft equals m2 times a. So we've got two unknowns here, ft and a. Those are our unknowns. Everything else is given. So we have two equations and two unknowns, and I'm just going to do a little isolation and then some substitution. So I'm going to isolate ft right here as m2 parentheses g minus a. That may not be the smartest move. I get that. But I'm just going to do it right now to get a handle on what's going on. And then what I'm going to do is I'm going to do a little substitution. Let's put these two formulas together. So we're going to have m2g minus m2a. I know, I expanded it out again. Pretty sassy of me. m1g sine theta equals m1 times a. And so here we go. I'm going to actually isolate a. m2g minus m1g sine theta equals m1 times a plus m2 times a. What? I brought m2a over to each side. Wow. So then we have m2g minus m1g sine theta over m1 plus m2 is in fact our acceleration. Pretty cool. And now what we're going to do is we're going to actually get the tension. I'm going to do something really obnoxious here. We could actually put in our numbers and get the sign. I'm going to actually get ft in terms of letters because I can. So check this out. This is going to be really, really exciting. And by exciting, I mean lots of algebra. So ft equals m2, okay? And check this out. G minus, here we go, m2g minus m1g sine theta over m1 plus m2. And now what I'm going to do is we're going to get some things on a common denominator. Oh, yes, we are. So here we go. We're going to say m2 times, now here we go. I'm going to make this thing here m1 plus m2g gross over m1 plus m2, okay, minus m2g minus m1g sine theta over m1 plus m2. And then we're going to simplify this even further. So this is what we're going to end up getting when we combine. I'm going to get that the tension force equals m2 out here, and let's get things in a common denominator. So I'm going to end up getting m1g. m2g here cancels the m2g here, okay, plus m1g sine theta over m1 plus m2. And so my tension force ends up being, the tension force equals m1 m2g times 1 plus sine theta all over m1 plus m2 when I solve. That's kind of interesting. Alrighty. So that is it for question number 3. I'll let you put in the numbers. Ha ha. Okay, now, number 4. You know what? I'm going to hold off on number 4 for another video because it's a lot to digest, isn't it?